So I'm going to talk about high dynamic range lighting, particularly with application in Unity, and just what high dynamic range lighting is in general, how to create high dynamic range lighting in Unity from source material that is already HDR, and also show how to create brand new HDRs from scratch using any 3D modeling program. I'm going to use Cinema 4D because that's what I'm familiar with, but you could use this technique in Maya or Max or anything in general. And so first, let me just talk about what an HDR image is. In high dynamic range image, for instance, this image right here, this is a high dynamic range image. Now you can't tell it's a high dynamic range image now because our displays are low dynamic range. That means that they can only display 256 light levels. No, thank you. They can only display 256 light levels of every color. So they have 256 red, 256 green, and 256 blue. And that's really all you can show. That's the full gamut of color levels that you can show on a screen. However, in an outdoor scene like this, there's actually a lot more light levels present, which is currently one of the biggest differences between a display and real life. In fact, I think that it's the biggest difference that's not been addressed yet. That once we have true high dynamic range displays in VR, that's going to be one of the major clinchers to make us feel, okay, we are outside right now. Because right now, when you go outside, and let's say you are glancing in your wallet, and you're looking in your wallet and it's kind of dark in there, but out of the corner of your eye, you're walking by water and there is the sun reflecting off of the water and there's these bright spots. The difference in brightness between that bright spot hitting your bright eye and the darkness that you can still see but that is not quite black inside of your wallet is a lot more than 256 steps. It's way, way more. Mm-hmm. So about 10 or 15 years ago, it's probably about 15 years ago now, somebody realized that you can actually put more information into a single image than you can present on a screen. You just can't show it all at once. And so this .hdr file, this is a radiance format file. There's a couple different formats. There's .exr, .hdr, and these are 128-bit files, 128-bit floating point files. That means they have 32 bits per channel rather than 8. And so the way you can tell, the first way you can know that something is different about this image and that this image can be used for lighting in 3D application is this. I've got to open in Photoshop, and if I go to Adjustments, Exposure, watch what happens when I bring the exposure down. See this real bright area right here? Imagine if you did that, if you just lowered the exposure to a regular JPEG, what would happen? But here, when you lower the exposure, see how it still stays bright? Even though the darkness under these rocks goes dark, there's more. Can you tell as I'm moving this that there's more there than meets the eye at any one level? Mm-hmm. See that? So when you blow it out like this, that's blown out, but now you've got all this detail in here. If you just did this to a regular JPEG, or well, here, let's do that. If I just go Adjustments, or let's just change it to 8 bits. We're just going to make this a regular picture. And this is where tone mapping comes in, Max, you were talking about. Because when you're going to go make that into a regular picture, there are several ways that you can go about doing it. What you're talking about is something generally called local adaptation in general, which is rather than just kind of burning in what you see on the image there in that first display that we saw, it figures out what the most optimal local exposure is in each section and will sort of burn that into it. You can also do just simple exposure and gamma. Let's change this. Let's just burn this down to 8-bit. Now it's 8-bit. So now if we go to Adjustments, Exposure, see, there's just not as much detail there anymore. So that's just to show sort of the anatomy of an HDR file. Now, the cool thing about an HDR file is because there are so many light levels there in the image, if you take and you wrap this image around your scene as a sky sphere, there's enough lighting information in this image such that it can be used to light things in your scene in a wide variety of lighting circumstances in a way that you just can't do if all you have is the data that you see there. There's not enough data to run into your shaders to figure out what things really should look like if you just wrap a regular image around the scene. So this type of lighting is called image-based lighting. It actually was pioneered a lot in, it was pioneered originally by a guy named Paul Debevec. There's a guy named Paul Debevec that figured out about 15 years ago or so now, he figured out if you go into an environment or any room and you photograph a chrome sphere at multiple exposures. So you take multiple exposures with your camera, you take a dark one, medium one, and a light one, and you fuse that together into a high dynamic range image, you will have captured the lighting environment of that environment, and you can use it to light three-dimensional scenes in a very realistic way. So in Unity, there is a, that looks familiar, right? There is a plugin in Unity called SkyShop, and I want to show it to you. Even though it is a third-party plugin, this is something that's going to be become a lot more foundational in Unity 5. I don't know if you can actually create these maps in Unity 5 this way. I think you might still need to use SkyShop for that. So I consider SkyShop to be an integral part of Unity right now for VR development, because HDR lighting is just so good for VR because it's relatively inexpensive. Because what we're going to do is essentially we're calculating our lighting right now. So it's sort of like we're going to bake our lighting. Something like baking, in the sense that you are pre-calculating things such that your CPU load and GPU load while you're running is actually quite low. So here's the SkyShop interface. So what we want to do is we want to process this image such that we can use it as a lookup to create not only reflections but also diffuse lighting. And here's the way that it works. First, we select the input panorama, and I've already copied that file into our directory, and there it is, Mono Lake Sky. I just copied that HDR file into our assets, into textures.
Why is it just white and blue?
You know why? Because Unity doesn't normally recognize HDR files, but SkyShop does. So see, if I take it out and say this is not an HDR file, it gets all blown out because it interprets it as an 8-bit file, 8-bit per pixel,
right,
and it doesn't look right. But once you recognize it as an HDR file, what we want to do is we want to generate, hey, what's up? We want to generate cube maps from that we can use to create local, specular, and diffuse lighting. So we're going to create a new cube map here, and there's a little bit of lag in this as it creates the cube maps, but it's not that bad. And then we're going to create a new specular map, and this is just creating these blank maps. So these are actual textures that are being created right now that are formatted such that they can be used as cube maps in Unity. And once they're both created, what we're going to do is we're going to set the quality up here to high. And we're going to hit compute. And now what this is going to do is this is going to do, for the diffuse lighting, it's going to do a convolution, is technically what it's called, on the image. It's essentially a better way of doing a blur. It's a blur that is better than just a regular blur. And see, it processes right here in the specular, it processes this file such that it can be used to look up even for blurry reflections. And this is what it's going to use for the diffuse lighting. It's basically processes into cube maps. So now that we've got this, we've got these two cube maps in our project called Mono Lake B, diffuse and specular, I think, or sky and specular. So now what I want to do is I'm going to go in here to this. We have a sky in here right now. Oh boy, we have a Unity out of memory error. And this is a thing that can happen, everybody. We all know that. So what I'm going to do is load back up Unity, and we're going to take those cube maps, which I believe it will have already captured. Let's make sure. Skies, sky. You know, can we dim the lights in here? It's really hard to. It's kind of blown out up there. That's better. Yeah, there's a fish in there actually. This is. I'll show you what I have right now on this. This is a thing I'm working on for later today. Hopefully, we're going to play with it in the holodeck later. So basically, where's this? Yeah. So basically, I rolled down the windows and we have fish swimming around. So what you're going to be able to do in there when we can walk around, you see the floor recedes, is you'll actually be able to walk to the edge, I hope, and you'll actually be able to see. Look, if we look here somewhere, there I got a fish swimming around. So we're going to be able to look in the water and see this Swiss fish swimming underneath. But see, that sky is a sky that I created in a similar manner to the one we created now. Now let's update it to use the sky that we just made. Bring it back in. I just had to do that as like an opener, you know? Let's roll down the walls.
Zach gets squished.
Yeah. Okay, so now what we're gonna do is we're gonna take that sky and we're gonna call this sky Austria because that's the name of the sky that we use, and we're gonna duplicate that. And we're going to call it Sky Mono Lake. That's what that is. Mono Lake. Now all we're going to do is go in here and select those cube maps as long as it filled them out. We might have to sometimes when it crashes at that stage, yeah, I have to regenerate them. Window, Sky Shop. Got to do that again. And we don't have to create those cube maps again, we can just select them and populate them again.
So I missed the beginning, it's just the input of Skybox? Or?
The input is simply this high dynamic range image. And I went over already what that means. It's a 128-bit file, which means there's more lighting information in there that meets the eye, because this was created by fusing at least 3 exposures taken with a regular camera that are shot at generally usually -2 exposure stops, EV, 0 and +2, and then you fuse them together into one file that has more information in it than you see, because I showed that if you change the exposure on this and you bring it down, you can see that even when you bring it down, see how the highlights there and the clouds are still present?
Yes.
You can't do that with a regular image. This is a special kind of image. If you blow it up like this, there's all sorts of dark data that's there, even though you can't see it when the exposure is down. So that's the input. And so now I'm showing how you can bring this into this SkyShot plugin in Unity, which will allow us to create, let's select mono, let's just pull those cube maps in here, which we created, and we're just doing this again because Unity crashed. It's very rare that it does that, probably 1 out of every 20 times or so. And now that we've got them populated, we're going to fill them in. And so what we're doing here, the fact that it takes a while right now is awesome, because it means when you're in VR, on a Gear VR, you're getting a lot of computation that you've already done. And you get a really cool look in a way that you can't do by just creating regular directional lights and spotlights and things like that in mobile right now. So we've got that. Now it's created those cube maps. Now we'll save our scene just in case it dies again. And we're going to go back here to Sky Mono Lake, and we're going to select this. I just need to select it again. There it is. So it created them. Now if we go and we disable the holodeck here so we can see out there, and we go up to Sky Mono Lake and we say make global sky, there it is. Now all of a sudden we're inside of that, and you see the water and everything looks like we're now in that place. And also if we create 3-dimensional objects in the world, even their diffuse lighting will, like even the fish. See the look of the fish here? See how it's got slight like blues on it? Like, so when I go in here, look at this material, how simple this material is. Now what's awesome is when I create a material, like for this fish, and I tell it to use the SkyShot materials, you can get this really great look that adapts with the sky. So if we go to Sky Austria now, watch how different that fish looks when we make that the global sky. You see that? So now, all of a sudden, you can create an infinity of looks just by changing the sky. And so let's look here at the other things that we can do with this. If we go here to our sky, or let's just look at this one we're working with right here, Sky Austria. Since this is a high dynamic range image, you have the ability to do things like in real time, in the game even, adjust things like the camera exposure, and see you still get that same effect of having that full range. See how the sun is really there down low? So you could, for instance, animate this to make a sunrise. In fact, I'll get to that in a minute. I have ideas of ways we could actually create a whole day-night cycle using this technique. So that's the basic idea of how to get a high dynamic range lighting into an environment like this. And to just show you how simple it is to create a material that uses this. If we look at this fish here, this koi fish, this has This is a type marmoset mobile bumped diffuse. Now, if we just made this bumped diffuse, or let's see, I don't know why I'm not getting anything on that way. Let's just put it back to marmoset bumped diffuse IBL. There we go. Mobile bump diffuse IBL. There it is. So here you can do things. For instance, these marmoset shaders are, I say, what you would call the very first most minimal foray into what you call physical base rendering. Has everyone heard of PBR, physical base rendering, the big deal about PBR? Physical base rendering is a system of rendering that models physical characteristics of surfaces, rather than the way that rendering and materials have been done for many, many years, where you just kind of fake things until they look right. Like different things like specular intensity, the way they've been calculated for years, they don't really have a physical analog or a realistic analog. They're just sort of arbitrary. But physical based rendering seeks to model physical things. And this is not a full physical based shader, but it has one thing that is very key to physical, which is Fresnel strength. Some people call it Fresnel, but it's Fresnel is the right pronunciation. Fresnel strength, and Fresnel has to do with the change in the reflectance of something based upon your viewing angle to it. You see it a lot, for instance, when you are driving down the road, and when you're far away from pieces of tar on the road, they're really reflective. And then when you ride over them, they're not reflective anymore. And so Unity standard shaders don't have that, but SkyShap does. So like, watch what happens when I make that angle higher. See that at the top of the bottom? It makes a tighter, shiny spot on that. So even just by modeling and changing your Fresnel strength on things, you can get a lot of really cool variation. And this all, you kind of get it almost for free because you pre-calculated this stuff. I want to show you one other thing, and that is something I just figured out how to do, which I think has a ton of potential, and that is how to create from scratch one of these skies. So I never tried this until recently. I said, well, how could I generate my own high dynamic range image? Like, let's say I just want sort of a gradient. Let's say I want to go real primitive, and I want to have a gradient that sort of imitates what it looks like to look out at a sky, but I want to light my scene with that. Well, it's not that simple just to make a high dynamic range gradient. How do you draw in high dynamic range? Well, here's one way I learned how to do it. This is using Cinema 4D, but this technique should be readily transferable to any other 3D app, although you might need to learn a little bit of its specifics of how to use that app to do this. So what we're going to do is let's create a sky first. One thing I love about Cinema 4D, it's really easy to create procedural things like skies, for instance. So I'm going to create a sky, and all a sky is a big sphere around us. If we render it, looks like nothing much. But now I'm going to create a material. I'm going to call this sky. And in Cinema 4D, the way you can create a cool sky is you can go into the color channel. Let's create a layer. Let's stack a couple things. What we're going to stack is first a gradient, and we're going to say we want it vertical, and let's just make it real simple. What would be a real simple sky would be sort of white here and blue up here. So we go like this and like this. We pinch that together. What's going on there? Why am I? Oh, because there's still a white stop there. There we go. And so we put this in the middle. So the middle here is going to be equivalent to sort of the equator. And so if we take this and we put this material on the sky, we've got a little bit, let's make it a little more noticeable. And so what we'll do for that is, let's bring that blue down more so it's closer to here. And you could get, real creative and make it pink and red and down there and all kinds of stuff. But we're just going to do a real simple one right now. So we've got something that looks sort of like a sky. Now on top of that, I always like to do one more step on here. Layer, shader, noise. Let's put a little, Cinema 4D is awesome because look at all these types of noise it has. Where's Ken? He would love this. It's got like 64 different types of noise that you can stack. So wavy turbulence, and I like let's stretch them out a little bit. So I'm just going to put some turbulence on top of there. make them really wide and narrow. And then we're going to go up here and we're going to set this to type screen or overlay. Like this. Now we render. There, we got like sort of a stylized sky. We got basics in there. Now, the thing is, you can't just take this and render this out, even though Cinema 4D can render in 128-bit. You can't just render this out and expect to be able to wrap it around a sphere and bring it into your environment. It's not projected properly. What we have right now is just a perspective camera on this. So there's this really interesting technique. Remember I said a while back there was a guy named Paul Debevec that figured out that you could take a mirror ball. I don't know if you were here at the time. He figured out that you could actually put a chrome sphere in the middle of a room and photograph it, thereby capturing the lighting environment of the room, and then transform that back into something you can wrap around the scene. There's this technique here that, let me save this so I don't lose it. So now, if we've got this mirror ball here, and all this mirror ball is a sphere with a perfectly reflective surface. And you can make this, I'm sure, in any 3D app. Now, if we render this now, what we get there is, now that looks more like what we need, what we want. We want to render something like this out so that when we wrap it around our sphere and go inside of it, we can use it as a sky. So the way you do that in Cinema 4D is you put this tag on here that allows you to bake the texture that's wrapped around that sphere. So if I go in here and I say, all right, I just want to bake this out to this environment sky, and I put it right in there. I'm going to say options. I'm going to say what size I want it to be, 2048 by 1024. Bake. And so what it's doing, it's actually going to bake out one of those maps that even though it's showing it as perfectly square here, it's going to be properly formatted like we need when we actually look at it. So if we look at it here, HDR sky, bake, and it's called, is this it, gradient? HDR sky render environment sky. Wait, where did it?
It's in a different.
Yeah, it's a different. That's right. I baked it before, and here it is. So we've got. Actually, let me fix that. Let me do that right. It went to the wrong place. So let's put it in bake. And we'll call it gradient sky 2. Let's try that again. We were baking it at 32 bits per channel. Now let's try that again. Bake. It should show up there in a moment. Now you can also put geometry in this scene too, to put cool stuff in the sky, structures or anything like that. Gradient sky 2, reflection. Wait, yeah, this is it. There it is. So let's see what happens. So now we just created that. Now that also, if we look at that under exposure, I believe we will see some interesting properties of this thing. Yeah, see how that white stays white? So we just created, look at that, we've got all that. We can blow it out like that, bring it down like that, and we've got all that range in this image. So now all I gotta do is take that, gradient sky 2, reflection, and bring it into our project. VR room, assets, textures, environments, gradient sky 2 reflection. Now it processes it for a minute. Gradient sky 2 reflection. There it is, and see it recognizes it as a high dynamic range image because it is. You have to create these 2 new skyboxes. And then we're going to go to high quality. And we're going to compute as long as Unity does not crash. Sometimes it does crash if you're doing this a lot. I think there's a memory leak in SkyShop if you're making a lot of skies in one session, but it looks like it's going to do it.
Good, all this computation occurs pre.
Oh yeah, I mean, it's amazing. So here we go. There we have our sky map and our reflection map, and that's called that was called gradient sky. So all we got to do to use that, let's save the scene so we don't lose that. And we're going to go here. We're going to duplicate that, one of the skies that we've already got. I'm going to call it sky gradient, and we're going to select gradient sky reflection. And this one, which was for the specular. And now let's set it as the global sky. You know, our exposure's a little weird on there, but that's because our exposure's down. But there we go. There we go. So we just created that. Look at those reflections and everything. And if we put things in the world like this fish, they are affected by it. So we just created a purely procedural, high dynamic range environment. I think that's pretty cool.
That's awesome.
Isn't that awesome? I have not seen this done, although I'm sure it's done. I haven't seen it talked about a lot, particularly in Unity. I bet they do this a lot in Hollywood for CG. They've got to be able to do this kind of thing, but kind of unique thing that I think is really a big win for us working in VR, because now think of the art direction possibilities. Now before you'd have to go out and say, well, what high dynamic range images can I capture or use? But now you can start from ultra primitives and design anything you can think of and use it as environments.
Is Cinema 4D free?
There is, I think, a personal learning edition. I don't know if it can do all this, but I'm sure that this can be done in, for instance, in V-Ray, the renderer V-Ray, the very famous renderer V-Ray, which is used in Maya, has actually a camera that does this automatically. It's a spherical camera. So you don't even necessarily need to go through that process of putting the chrome sphere in. But yeah, I think it's just so cool that it's taking something in the real world, like photographing a chrome sphere and doing it in a 3D app, yields this result. So the next things that you can do with this is, I'm not going to get into it right now because I have not perfected it enough myself just to be able to click, click, click and do it right now. But one limitation of this, let's look at a limitation, how to overcome it. A limitation of this is that if we turn on this holodeck here, and that if we put an object in, like let's say we put that fish in the room, it's still going to be, oh wait, where's this? Circle.
It's still going to receive.
It's still going to receive the reflections from outside. So see, it's not seeing anything in the room reflected, but there's a way around that. And I'm just going to tell you about it right now. And that is, SkyShop supports this, and Unity 5 also supports it natively. And that is, you can define a region and press a button, and it will create a special environment map that gives you the local reflections of what you're inside. So let's say it actually puts a camera there and essentially photographs spherically everything you've got in the environment, even static objects that you've built in. So if you built geometry in, you can get local reflections, and they actually work really well. And it will even handle things like, for instance, let's say we knocked out the walls on here, such that if your object travels through the sky, it will get the sky reflections, and then as it travels through the room, it will get the room reflections, and then it will get the sky reflections again. So it's possible in Unity 5 even to create a whole bunch of these reflection probes and move them around your scene, so you can get a lot of control of pre-computing your local reflections. So you can do that, and you can also there's other forms of baking that you can do to using this technique of what's called light probing, basically filming from some location you were seeing and then using that as a lookup later on, but that is for another day.
One thing that I was curious about is how exactly is it integrating into the, like, is it using global illumination?
Is it using global illumination?
Like, how does it, do all that complex lighting?
It's actually really, really simple. Would you call it global illumination? In the loosest sense of the word, I think there is a sense of word that you can call it global illumination. It is not indirect illumination. That is, It does not model bounces of light. Which is why it doesn't work. Although with light probing, you can probe again and again and actually create more bounces, which is kind of another topic. But it is global in the sense that it is, here's the way that it's doing it essentially. The way I like to picture it in a non-technical way, imagine if you had a really, really large, imagine we had a really large flexible sheet of LED lights that we could light up with an image. Just like one of these screens that's on Times Square. Imagine if it were made of flexible material. And imagine if we were in this room, we had a glass sphere around us, And imagine if we were to wrap that screen around the room of flexible LED lights, and then we put a chrome sphere or anything in the room. What's it really doing? All it's doing is for every point on that sphere, it's finding the normal, the direction up, and it's just doing a lookup into the texture to say what color is it there. Now, the kind of novel thing here about SkyShop is that it's always been possible to do this for many, many years with basic cube mapping reflections, where you could get really stark, distinct reflections, but you couldn't get diffuse lighting or soft lighting that way. And so the way that SkyShop solves it is it pre-convolves or pre-blurs, pre-diffuses, as it were, the image data beforehand. Essentially, you might just think of it as a blur, so that when it's doing those lookups for the diffuse component, it's looking up into a map that has already been diffused.
Right.
So it doesn't have to figure the diffuse component on the fly.
Right. And because you have that HDR image, you can kind of express all the levels of brightness that you might otherwise miss. Right?
Exactly. And then you can even adjust the exposure later and sort of dig into that data set that you have around you that represents the lighting.
It's actually super fast then.
It's really fast. In fact, as far as the another advantage of this, it is light on the GPU such that Zone, my game, does not overheat. And a lot of gear games overheat real quick. If you're rather trying to do fancy shaders that have to do a lot of calculations internally to create cool lighting effects, many times that will be very costly such that your frame rate will be okay, but you will be pushing your GPU to a level that's going to overheat after a certain amount of time. And these are actually really, really, really efficient on the Gear VR because the Gear VR happens to be very good at texture lookups and textures in general.
Right.
And so it's pretty much ideally suited.
Awesome.
There are some limitations to this too, that you're not getting shadows here directly, but there is a cool little technique you can do to sort of fake that. And that is if you have a sky, for instance, like right here, if we have a sky like the Sky Austria, it just takes a minute here, it's lagging. Make the global sky, and then you see we've got a sun over there. Well, what you can do is you can put a directional light coming from there. In fact, you can even there's ways even to figure out how to map your directional light to where the sun is in the scene, such that you will get basic directional reflections that basically line up with the scene. So some people will look at this and say, well, you can't do this, you can't do that, you can't have local lights, you can't have local shadows. Yeah, but it's kind of I've just been saying, let's just go artistically with a choice that says we don't need that. Let's see what cool stuff we can make with this, because I think it gives a really cool look on its own.
I think this will provide a much more of an environmental experience than if you're able to see the local shadows or something.
How so? The local, you mean without the local shadows?
No, I'm saying like if we dedicated all our time to something where we have perfect like shadowing and stuff compared to like a really bright, powerful scene like that, I think we'll get a lot more out of going through.
I think so too. I mean, the fact that you can, and also you can actually create these very easily now with this little guy here. I mean, I could create one in this room right now if we wanted to. I don't think I'll take the time, but with this little guy here, this little thing called the Ricoh Theta, it's just a little camera that with one button press will capture an environmental map, and you can actually create multiple exposures with this, take multiple exposures of different light levels and fuse them together in Photoshop to create these maps. So I carry that with me, and sometimes I'll be at a hotel lobby and there'll be a cool atrium or something. Bam, just you can capture things like that. And one final technique I want to show you is that it's very possible to do let's say to do things at this level here where we've got this HDR image, to pre-process your image creatively. Like for instance, let's say you don't want to have this huge rock outcrop around you and you just want sort of a more open horizon. Well, no problem. What is the size of this image? This is 1600 by 800. So just select a fixed size. Let's select 800. So I'm just going to copy that, paste it, move it over. And then edit, transform, flip horizontal. Now guess what? We've got a sky that we've just pre-calculated to our needs. And maybe you want to flip it vertically. Now all of a sudden you flip this thing vertically and you have a complete open sky expanse where you're going to do something with flying or something like that. You don't, in other words, you don't need necessarily capture exactly what you need. Sometimes you can make it at this level. And I believe that is all I have to say right now.